Okay, let's talk about nodal analysis, or in some places it is also called as node voltage method. What is a node? It is the connection point between two or more than two circuit elements. But when we are doing our nodal analysis, we will only consider that node which is called essential node, or in some places it is also called primary node or important node. The node that is connected to three or more than three branches or circuit elements. We would talk about that node. Now, there is another node as well, which is called a reference node, which will always be on the bottom of the circuit, and we will always assume that it has zero voltage. Okay, node is just a connection point between two or more than two elements. Let me show you what is a node. This is a node. This this point between R1, R2, and this branch. This is a node. This is a node. This is a node. These are important nodes. Why? Because they are all connected to three parts. Now this node here is also a node which is connected between R5 and this branch. But this is not an important node because it is only connected between two branches. Similarly, this is also a node but not an important one. So these are the nodes, these connection points here where the circuit joins. Now whenever we are talking about nodal or nodes, the law that comes into our minds is actually Kirchhoff's current law. Because we say that currents entering a node must be equal to currents leaving a node. So that is Kirchhoff's current law. So we are talking about Kirchhoff's current law and node. But what is nodal analysis? It is a different thing. What is it? It's circuit solving technique. For example, you know how to add numbers, you know how to multiply numbers. Similarly, nodal analysis is a circuit solving technique. For example, somebody gives you like this circuit and ask find the node voltages here, node here, node here. So in order to find the node voltages, you would apply nodal analysis. It is a technique, a way to solve a circuit. So what do? You apply nodal analysis on a circuit. What does nodal analysis do? This technique will make you calculate the voltages on the nodes, on on this node and this node. You would be able to find the voltages here. What is the voltage here? Now, of course, if this is a not a current source, a power source, then you know what is the voltage here, but you don't know what is the voltage here. What is the voltage here and the voltage here? So nodal analysis will give you the voltages at the nodes. Although node is concerned with Kirchhoff's current law, but this is a reverse thing. It will give you the voltages at the node, and by finding the voltages at the node, you can easily find many things. But you are just concerned in finding the voltages at the nodes. So once when you find the voltages at the node, your work is done. But the question is, how are you supposed to find the voltages at the node? So what we do is that we would write node equations. Nodal analysis is the technique in which we find the voltages at the nodes with the help of Kirchhoff's current law. It's reverse. Kirchhoff's current law is associated with currents, but by that current law, we will find node voltages. That's how it works. Okay, so nodal analysis is to find the voltages at the nodes with the help of Kirchhoff's current law. So let's see how are we supposed to find the voltages at the node. I will say it in Urdu as well. नोडल एनालिसिस में हम ऐसे करते हैं कि हम जो नोड्स है, अब नोड्स जो है वो तो रिलेटेड है किस चीज के साथ? किरचॉफ्स करंट लॉ के साथ। लेकिन हम क्या करते हैं कि नोड्स पर वोल्टेजेस निकालते हैं किरचॉफ्स करंट लॉ की मदद से, जो कि करंट लॉ है, लेकिन उस करंट लॉ की मदद से हम नोड्स पे वोल्टेज निकालते हैं। और जो हमारे पास किरचॉफ्स करंट लॉ की बात आती है तो हम क्या करेंगे? हम सिर्फ और सिर्फ नोड्स पर इक्वेशन लिखेंगे। नाउ रिमेंबर वन थिंग मोर, what is Kirchhoff's current law? Sum of currents entering a node must be equal to the sum of currents leaving a node. Another statement, all the currents uh, entering a node must be equal to, or all the currents at a node must be equal to zero. That means that overall it should be 0. It means that the entering must be equal to the leaving, so they will counter each other and the sum will be equal to 0. It also means that if a current is entering and another current is leaving, you cannot sign them the same. For example, if you are saying that the entering current is plus I1, then the leaving current cannot be plus I2, it will be minus I2. So just remember this single point. The entering and the leaving current would not have the same sign. They would have different signs. Okay. Now let's talk about the steps involved in nodal analysis. I will also share a video on your class portal, which is in English, and that guy has explained it so well. If you guys don't understand my lecture, also because he's doing it on the board. Okay. Now, what do we do? First of all, when we are given a circuit and we are asked a question that apply nodal analysis on it, first of all, we will identify the essential nodes. How many nodes are? For example, we have this circuit. So when the question is find nodal analysis. So what will I do? First of all, I will say how many nodes are there. This is node, this is node, this is node. We do not consider the bottom nodes, but yes, the bottom has a reference, one reference. If you see, all these wires are connected to this one wire. So this is our reference node. So what we will do, we will say this is 0 voltage and this is our node 1, node 2, node 3. Then what we are going to do is we are going to label them for our easiness. So I will say node V1, node V2, node V3. Let's suppose the voltage is here, because we are supposed to find the voltages at the nodes. So definitely we are going to name them. So let's say the voltage at node is V1, at this node is V2, and at this node is V3. So our purpose is to find V1, V2, and V3. That's what we are supposed to do. After that, when we label them, in some places they are labeled VA, VB, VC. It's upon your choice. Now, when we name them V1, V2, V3, the next step is we will write node equation. Now, this is a node, and we are saying that we will find the node voltage here with the help of Kirchhoff's current law. So, what are we going to do? The only thing we will do is we will write the Kirchhoff's current law equation at this node, then at this node, and then at this node. And then after that, we will only simplify it. So remember, in nodal analysis, the important thing is the identification of the correct nodes and writing the node equations. Once you write the node equations, then after it, it is only maths, which is only simplification. So your node equations are correct. Your 90% question is correct, because after that, you will just solve it. So let's see. Now this is our first example. We have selected this as our reference node. Let's say this is V1, this is V2, and this is V3 in the next slide. It is very difficult to put these things on the circuits, these red lines. That's why they would be a bit rough, but I have tried. Now this is our node V1, this is our node V2, and this is our node V3. It can be any circuit. For example, it's 4 circuit, 5 nodes, but the maximum node in a circuit that I will give you in exam would be 3, because it is difficult to solve 4 or 5 nodes with the help of calculator. So our nodes will be 3. Now this circuit has actually 4 nodes. See, V naught. This is the reference node, but we do not write the equation of the reference node. We only write the equations of the nodes that are on the upper side of the circuit. Now, once we identify the nodes, now in books and in any lectures, we say that now we will write the equation, the KCL equation here, the KCL equation here and here. Now, when you think about currents, okay, what is the current here? Is it entering here? Is it leaving here? What about this area, this area? That is so ambiguous, and that is the only difficulty when we are talking about nodal analysis. But again, it has been so easy for you. What we are going to think is that we are going to assume that all the currents, let's suppose, are leaving V1. Okay. So if you are assuming this, then our question is more easy. If every current is leaving this node V1, then it is very easy for us to write the node equations. Okay, now I will say it in Urdu. देखिए, अगर हम ये सोचने लग जाए कि ये करंट यहाँ पे एंटर हो रहा है, ये लीव हो रहा है, लेट्स से ये वोल्टेज सोर्स है, तो वो हमारे लिए बहुत मुश्किल हो जाता है. हम अपनी आसानी के लिए क्या करते हैं कि हम ये एज्यूम कर लेते हैं कि लेट्स से इससे तमाम करंट्स निकल रहे हैं, लीविंग है, यहाँ से भी तमाम लीविंग है, यहाँ से भी तमाम लीविंग है. इससे कोई फर्क नहीं पड़ेगा। अगर आपका आंसर माइनस में आ जाता है तो भी उससे कोई फर्क नहीं पड़ेगा। तो ये एक बहुत सिंपल टेक्निक है। इस टेक्निक को फॉलो करने से आपकी आधी से ज्यादा जो प्रॉब्लम है वो सॉल्व हो जाती है, कि जब आपको ये सोचना ही नहीं पड़ेगा कि क्या डायरेक्शन है, बस आपने ये एज्यूम करना है। और लेकिन ये साथ में लिखना है कि लेट्स एज्यूम द ऑल द करंट्स आर लीविंग द नोड्स। दैट इज सो इजी। अब हम क्या करेंगे, V1 हमने नोट लिया और हमने assume किया that all the currents are leaving. So let's write the equation, the KCL equation at node V1. What is the KCL equation? Sum of all the currents at a node is equal to 0. Now we have assumed that all the currents are leaving the node. Now let's say this current is leaving the node, but this current's value is already given. It is 2 ampere and this current is also leaving. So that means the current in this branch is 2 ampere. So we'll write 2. As we have wrote plus with 2, now what about this current? This is also leaving. So let's say it is I1, because let's say it's entering R1, so it is I1. Plus I1 is also leaving. Another current is going towards R2, so we will write it I2. So say 2 plus I1 plus I2 is equal to 0. This is our first node equation. Now let's write the node equation at V2. This is I2, this is I3, and this is I4. So again, I3 plus I4 plus I2 is equal to 0. Now V3, this is I3, this is I5, and this is IS. Now IS is actually entering the current. We have assumed that it is leaving the current, but it is entering the current, so you cannot sign both. Here it is given, that's why. We will write I3 and I5 as plus, but IS would be minus because it is entering and it is given. These others we are assuming leaving because we haven't been supplied with the directions, but here they have given us the direction. यहाँ पे उन्होंने हमें बताया हुआ है कि देखिए इंटरिंग कर रहा है, इसलिए हम अपनी तरफ से एजम्पशन नहीं कर सकते, इसको हम एज इंटरिंग लेंगे। दैट्स वाई हमने इसके साथ माइनस लगाया। बाकियों के साथ तो हमें नहीं दिया हुआ, तो जिसके साथ नहीं दिया हुआ उसके साथ हम लिविंग लगाएंगे, जिसके साथ दिया हुआ फिर वही लगाएंगे। ओके, नाउ वंस वी रोट these node equations, there is another thing that is a bit difficult for most of the students, but I will give you an easy way to solve it. Now, once we wrote these equations, V1, V2, V3, these are our node equations. We have to find V1, V2, V3, but we are not supplied with the value of I1. Instead, we have V1 and R1, V2, R2, and these values. So what are we supposed to do? We know what is Ohm's law. V is equal to IR, and if you want to find the value of I by Ohm's law, I is equal to V by R. Voltage divided by resistance is equal to I, current. So what we are going to do is we are going to replace these currents I1, I2 with V by R, which is okay. But how? Now I1, look at I1. It is this current which is going through R1. So what are you going to write? V1 by R1. How? Because you are going to see that after V1, what is the voltage coming here? No, it is V0. So in reality, you will write V1 minus V0 divided by R1. But there is no need to write V0 because it is zero voltage. So you would just write V1 divided by R1. आप V1 से जाएंगे और देखेंगे कि करंट जहाँ पे जा रहा है उसके एंड में कौन सी वोल्टेज आ रही है, वो आप इससे माइनस करेंगे। इसके एंड में क्या आ रहा है, इसके एंड में तो जीरो वोल्टेज आ रहे हैं, तो उसको माइनस करने से कोई फर्क नहीं पड़ेगा। तो आप लिखेंगे V1 डिवाइडेड बाय R1। ये हमारा हो गया I1। नाउ I2 is, you are going to go from V1, what comes at the next point? V2 comes at the next point, so you are going to write V1 minus V2 divided by R2. Remember, when it is the turn of this node, this current will always, this V1 will always be written as positive and others will be written as negative. For example, we say V1 minus 0, V1 minus V2, and if here was some voltage, then we will say V1 minus that voltage. But here we have V2, so we will say V1 minus V2 divided by R2. This is our I2. Now, why am I writing V1 minus V2? Because here I am applying Ohm's law, but that is a very difficult thing. Sorry, not Ohm's law. Here I am applying Kirchhoff's voltage law, but in order to understand that, it will be a bit ambiguous. I do teach it in regular classes, but I skip it in summer. So you just remember it that we will encounter another voltage, and whenever whatever is the other voltage, we will subtract it from our node voltage, which we are finding. So our equation would be 2 plus V1 divided by R1 plus V1 minus V2 divided by R2. That it is. Our first node is done. Now let's look at our second node. These are also written here as well, but I will teach it from here. Now let's look at three currents are going. These are the branches. So every branch must be covered current because current is going in every direction. If there was another branch at the upper side, then we would write a current going at the upper side as well. Now what about this current, which is I2? So here we wrote V1 minus V2 by R2, but now it is V2's turn. So in V2's turn, you will write V2 minus V1 divided by R2 because now we are considering V2. Now what about I4? We will write V2 divided by I4 because we actually say V2 minus 0 divided by I4, but V2 by I4. Similarly, at this side, I3, V2 minus V3 divided by R3. That it is our second node. What about the last node? I3 is this current. V3 minus V2 by R3. Now, the direction of the voltage is reversed. Similarly, V3 divided by R5. What about this current? No, we already have current and the values are usually given, so there is no need to write V equation of it because we already would have. Is wouldn't be given like this. It would be either 2 ampere or 3 ampere or any value. And once you write the equations, everything is done. Now, either you solve them by matrix or by simultaneous equations, you will find V1, V2, and V3, and your question will be done. But let's do it with a real example. Now, this is our real example. We have three meshes here, two nodes here. This is our node V1 and this is our node V2. Another thing, in order to make it easy for you guys, I won't give you very much difficult questions because this is summer and it is very hard to teach you guys nodal analysis online. So I would give you a few examples through an assignment, and if you guys learn those examples, then I promise you that I would give the circuits from those examples because I don't know another way it would be very difficult for you guys to understand. I mean, it is very difficult for me to teach you here online. Okay, now we have two nodes V1 and V2. What are we going to do? We are just going to write the node equations. Identification of the nodes is difficult, but once you understand it, it will be easy. Okay, so let's write the node equation at V1. Let's say this is the current coming here. So what I'm going to write, this is directly going to the reference, which is 0. So V1 by 10. What about this current? We already have the value of this current. So no need to write V1 minus V2. Why? Because we are not given the resistance. So we will write minus 2. Why? Because we are assuming all the currents are leaving the node. But here, this is entering. So we will write minus 2. What about this one? V1 minus V2 divided by 5. This equation is done. Now let's talk about V2. Again, assume all the currents are leaving, leaving, and leaving. So if this is leaving, we will write plus 2. This is leaving, we will write plus 4. What about this? V2 divided by 20. What about this? V2 minus V1 divided by 5. That is done is equal to 0. Now, the next step is solving, which is very easy. So how you are going to solve? What I do is that V1 by 10. So what I do, I divide 1 by 10, which is 0.1. So I write 0.1 V1 plus, then I divide 1 by 5. So what is 1 by 5? 0.2. So then I multiply 0.2 with V1 and with V2. So I write 0.1 minus, no, 0.1 V, 0.2 V1 minus 0.2 V2. See, 0.2 V1 minus 0.2 V2 is equal to 2. 2 has been transferred to other side of the 0. Similarly, again I divide 1 by 5, which is 0.2. 0.2 V2 minus 0.2 V1 plus, and 1 by 20 is 0.25. 0.25 V2 plus 2 plus 4 becomes 6, but when they come at this side of the 0, it becomes minus 6. So see, these are our two equations. 0.3 V1 minus 0.2 V2 minus 0.2 V1. Why 0.3 is here? Because we have added the like terms, 0.1 plus 0.2 and minus 2, because they both have V1. So we will add them and minus 0.2 v2. Similarly, here we have two equations. 0.3 v1 minus 0.2 v2 is equal to 2. Minus 0.2 v1 plus 0.25 v2 is equal to minus 6. So this is a simultaneous equation. You can solve it by simultaneous equation, or you can solve it by matrix. I will try to search the video of simultaneous equation if I can find any. Now I have this. You can easily solve this with the help of a calculator in seconds. There is even no need to put it in a matrix. But I don't know if that method is available on the internet. But if it is not available on the internet, I will uh, I will do it myself and take pictures of every step and post it here, so that you guys would know that how easily we would find the values. Now, if you put them in a matrix, it will look like this. See, zero point 0.3 minus zero point 0.2, zero point 0.3 minus zero point 0.2, minus zero point 0.2, 0.25, and 2 and minus 6. 2 and minus 6, and this is V1 and this is V2. You can also solve them by matrix, but I won't go for the matrix. The simultaneous equation method is more easy than the matrix. So when you solve them by simultaneous equation, your answer will be minus 2, but it will be displayed as x, and the other will be minus 40, which will be displayed as y in the calculator. So I hope that most of you guys know the method of simultaneous equation on calculator. But if you guys don't, then you can ask me. I will again post pictures of that method. Okay. Now let's come at this example. This example would be a bit difficult for some of you guys. But look at this circuit. We have actually three nodes, V1, V2, and V3. But look at this node. Look at this node. What is the voltage? Actually, V1 has the same voltage as 12 volt. But we cannot say V3 is 6 volt. No, V3 cannot be 6 volt. V3 is minus 6 volt. Because if minus to plus is plus, then plus to minus would be minus. We cannot give them the same sign. We already have these voltages. Now we can easily find V2. How? We'll only write the equation of V2. So we will say, assume all the currents are leaving V2. You see V2 minus V1 divided by 12 plus V2 divided by 6 plus V2 minus V3 divided by 12. And we already have the values of V1 and V3. We will substitute them and we will get the value of V2. See, we substituted the values and we got V2 as 1.5 volt. तो इस तरह के भी एग्जाम्पल्स आ सकते हैं जिस जो बड़ी आसानी से सॉल्व हो सकते हैं. Now this is a very easy example. You can just solve it in a few minutes because V1 and V3 are given. You are only going to find V2. Okay. This is another example. Now, let's see. Now look at this example. We have nodes here. This is our essential node and this is our essential node. This is not an essential node, neither is this an essential node. Now, if I want to write the equation, let's say this is our V1, this is our V2. That's it. Only two nodes. So how am I going to write the equation? V1, what is the voltage here? It is not 0. If this was not here, then it would be 0. But what it is 3. I will say V1 minus 3 divided by 1 kilo ohm. This is our I, first I. Yes, if this was plus minus, then I would write V1 plus 3. But this is minus to plus. So I will write V1 minus 3 divided by 1 kilo ohm. This is actually voltage. Now here, V1 divided by 2.2. V1 minus V2 divided by 1.5 kilo ohm. Now let's look at V2. If I am going to write this current V2 minus V1 divided by 1.5. What about here? Very easy. This is just like this branch. V2 minus V2 minus 4 volt divided by 3.3. V2, what is here? This is 0. So V2 divided by 820. You do practice on different circuits and you would easily understand the concept behind it. Again, let me see, wait a minute. I have posted a video on section B's class. I will also post it here in your class. Please do. This is actually your classroom's link. I don't know what is, but okay, I will share it again. I will share it individually. Now, the only important thing in nodal analysis is that the identification of nodes. When we were doing it, it was very difficult for us to identify the nodes. But once when you identify the nodes, then writing the node equation is very easy. And I am 100% sure that once you write the node equations like this, then solving is just mathematics. It is not something, uh, what can I say? It is not something what conceptual. You just solve it. I mean, anyone can solve it. The only difficulty is to identify the nodes and to write the equations. But once you identify the nodes and you write the node equations properly, then it is easy. But remember one thing, the best thing is that you will always assume all the currents are leaving the nodes and writing those node equations. The difficulty is that sometimes the students get confused in, for example, V2 minus V1 by 12. This is the only difficult thing. And again, I'm giving you another trick that the easiest thing is that when you are writing the value of this current, go from V2 and at the end where another voltage encounters, that is it. You would then subtract that voltage. देखिए जब आप इसको ट्रिक तरीके से करें तो आप क्या करें कि जब आप V2 की इक्वेशन लिख रहे हैं तो आप V2 से जाए और कहाँ तक जाए जब तक आपके नजदीक दूसरा कोई पावर सोर्स नहीं आता। यहाँ पे हमारे पास दूसरा पावर सोर्स क्या है V1 है तो हम लिखेंगे V2 माइनस मतलब दूसरी कोई वोल्टेज की वैल्यू नहीं आती माइनस V1। इसी तरह जब यहाँ का करंट लिखेंगे तो जाए कब तक जाए जब तक दूसरा वोल्टेज नहीं आता। हमारे पास V3 है तो हम लिखेंगे V2 माइनस V3 बाई 12। यहाँ से जब जाएंगे तो भी जाए यहाँ पे तो ये 0 वोल्ट है ये ग्राउंड है तो हम लिखेंगे V2 माइनस 0/6। लेकिन माइनस 0 अक्सर नहीं लिखा जाता उसकी लिखने की जरूरत नहीं है तो V2/6। दैट इज हाउ we do nodal analysis. To be honest, nodal analysis when we were students was so difficult for us. I mean, I still don't know how I solved it and how we cleared it. But this is the most toughest topic you guys would encounter. After this, it is so easy. It is only theory, and there are only three more topics of circuits left. I have removed Thevenin's theorem and Norton's theorem because I know that no matter how much I try here online, it will be very difficult for you guys to understand Thevenin's and Norton's theorem, and we have very less short time. We would not go for Thevenin and Norton, but nodal and mesh are important. So is superposition and maximum power transfer. We will only do these four theorems, these four circuit analysis techniques, and after this, everything becomes theory, which is so easy. Any questions?
मैम एक्सक्यूज मी, वो लास्ट क्वेश्चन में वो एसेंशियल नोड्स आपने